DBSCAN, or also called as density-based spatial clustering of applications with noise, and that's the reason we call it DBSCAN. DBSCAN is an unsupervised clustering algorithm that groups data points based on density, making it particularly effective for identifying clusters of arbitrary shapes and for handling noise, which is outliers. Now, DBSCAN requires two parameters. One is the EPS, which is the maximum distance between 2 points to be considered neighbors, and minimum samples, which is the minimum number of points required to form a dense region. So let's go ahead and implement and code for DBSCAN in Python. So go ahead, I have a profile already open. I'm going to first start with importing the necessary libraries. From sklearn.cluster import dbscan. This imports the dbscan class from scikit's learns cluster module. dbscan is a density-based clustering algorithm that groups data points that are close to each other based on distance and density and labels points that don't belong to any cluster as noise. Next, we'll import numpy as np, which imports the numpy library, which provides support for numerical operation and array manipulation in Python. Next, I'm going to get some sample data. I'm going to use the same one as previous example, which are points in 2D space. So I have those points available here. Here, x equal to np array defines the feature data x as a numpy array where each sublist represents data points in 2D space with two values, x and y coordinates. For example, the coordinate 1, 2 and also 8, 7 are 2 points in 2D space. The shape of x is 6, 2, meaning there are 6 data points with 2 features each. Next, let's initialize and fit the model. So to initialize, I'll say dbscan EPS equal to 3, min samples equal to 2. As I mentioned earlier, this initializes a dbscan clustering model with the following parameters. EPS equal to 3 specifies the maximum distance between the two samples for them to be considered as in the same neighborhood. The distance defines the reachability of points. Min samples equal to 2 specifies the minimum number of points required in a neighborhood for a point to be considered a core point. If a point has at least min samples points within its EPS radius, it forms a cluster. Otherwise, it may be labeled as noise if it doesn't belong to any cluster. Next, let's do dbscan.fitx. This fits the dbscan model to data x. dbscan forms clusters based on the density of points, where each point is classified as either a core point, a border point, or noise. The algorithm does not require specifying the number of clusters in advance, as it finds clusters based on the density. So let's go and get the labels. -1 indicates noise in this case. So I'm going to start with labels equal to dbscan dot labels underscore. Now the labels, this retrieves the labels assigned to each data point in X after fitting the model. Each label represents the cluster to which the point belongs. Points that are part of a cluster are assigned to a positive integer label. Points that are considered noise, that is, they don't belong to the cluster, are assigned to label of -1. Let's go ahead and print these labels to see how it looks like. So I'm going to save this and go to my command prompt or terminal and say python dbscan, run this, and you'll see labels 0, 0, 0, 1, 1, -1 based on these points that we have. These are the labels that are created for these, which means this last point, which is pretty much outside of the numbers that we have here, are considered as noise, and others are considered as one cluster. These ones are considered as cluster 1. So that's how they are labeled here. So this code demonstrates how to use dbscan to cluster points in 2D space. dbscan is useful for identifying clusters or arbitrary shape and handling noise, which is represented by points with the labels -1. The algorithm groups points that have a high density and identifies sparse, isolated points as noise. So I hope you were able to follow along. If you have any questions or had any issues, let me know and I'll get back to you.